Hello, my name is Michael Carr, and together with Stephen Graven and Drew Ritter, we modeled an earthwork process for Archer Western contractors and their massive Corridor X I-65 interchange project in Birmingham.
This slide shows the outline of the presentation. The project matched the four objectives from the syllabus. Contractors on the project are Archer Western. Project duration is 4.5 years. We visited the project site on September 13th and November 17th of 2011. The project is valued at $168 million. That is the largest single contract AlDOT has ever issued out. Construction involved enormous mountain moving operation. Project scope was to move 3.7 million cubic yards of earthwork. One of the best things about AlDOT's mission is it will alleviate some of the traffic congestion on I-65 by creating an interchange from I-65 to the future I-22. Due to the complexity and dynamic nature of the site, we consulted with Archer Western regarding a suitable modeling activity that would be finite enough to measure, repetitive enough to statistically analyze, and flexible enough to be altered for sensitivity analysis. The design team selected an earthwork process that required cutting of an embankment, hauling a quarter-mile to fill a site, dumping, spreading soil, and finally compacting. The portion of earthwork under evaluation was expected to produce 30,000 compacted cubic yards. The selected process is depicted below with an aerial photograph of the project site.
In order to create an appropriate model, the design team studied the earthwork process over the course of a workday. We collected equipment, type, cost, and time data. We found that a Cat 349 excavator is used exclusively for loading. 2 Cat 740 off-road dump trucks are used for hauling. 2 on-highway trucks supplement the hauling process. A Cat D6N dozer is used for spreading, and a Cat 815F pad foot roller with blade attachment is used for compaction. Equipment costs were derived from the current Federal Highway Administration allowances within the Equipment Watch's rental rate blue book. These are shown in a chart in an hourly rate. Likewise, we accumulated equipment operator costs, which for this contract are subjected to Davis-Bacon wage rates. Consultation with the contractor resulted in the hourly wage provided in the bottom chart. The majority of time, however, was spent tracking durations of activities within the model. We logged over 20 time trials of the various activities and then performed a statistical analysis in order to provide duration input to the model. Using Microsoft Video, enhanced by the Stroboscope add-on software, we created a flow chart of the model composed of normal activities, combi activities, queues, and flow arrows. Next, we assigned durations to activities using a triangular variable distribution from the collected data. Then, resource data was provided, and finally, applied availability constraints were also considered. A picture of our baseline model is shown. Notice the 2 competing haul cycles by on-road and off-road hauling trucks. After the baseline was created, it was executed through EasyStrobe software. The team spent a great deal of time validating the constructed model to make sure it was a fair representation of Archer Western's current earthwork process. The parameters for validation were to, number 1, achieve the contractor's daily production rate of 5,000 cubic yards per day. And secondly, visually inspect the model to ensure field-observed constraints were imitated. After hours of manipulation, our model produced reliable results that accurately represent the contractor's daily production rate. Furthermore, we observed in the model animation that the excavator, dozer, and compactor's influence was secondary to the haul trucks, which constantly cycled while others waited. This pattern reflected reality. Although the model was sufficiently validated, we took down some notes in order to influence our final conclusions. Conducting the sensitivity analysis for process optimization would be flawed without considering these factors. Firstly, Archer Western provided some valuable input listed here, so it is valuable to know that this activity is not on the critical path. Therefore, the contractor is cost and resource conscious on the process, since other critical earth-moving operations nearby demand his first priority. Finally, there are some limitations regarding EasyStrobe. We discovered that EasyStrobe results were scalable, whether initiated soil quantities were 30,000 or 3,000 or 300 cubic yards. Resulting times were comparable in factors of 10. Therefore, it should be considered that EasyStrobe does not account for economies of scale or disruption inefficiencies. This is significant in considering the contractor's vast earth-moving scope.
By manipulating our model with varied resources and constraints at a 10% scale of the overall process, we were able to compute overall completion times. Highlighted are the two lowest overall completion times. Having these times considered, we now must secure costs for additional equipment and the construction of the roundabout. This figure represents hourly operation costs once an additional dollar amount has been factored. When additional equipment was included, a one-time mobilization cost was considered. When load orientation was varied, the design group considered a one-day construction time in which labor and equipment rates applied to the reorientation construction and not overall production. From our study, the group determined that with no change in load orientation and the addition of 2 off-road trucks, efficiency was increased by 7%. The group also observed that for 1 off-road truck and the addition of a roundabout load orientation, a 15% increase in cost efficiency was realized. At this time, the group employed some critical thinking with the productivity output and cost information discussed. With a given earthwork process and already discussed feasibility considerations, the contractor might be best served by keeping the baseline process in motion. As discussed, the contractor is not afforded unlimited resources and operation is not considered a critical path. Gains from the baseline between 7% and 15% are modest and require upfront cost to change. However, the sensitivity analysis did offer insight regarding most cost-wise means for future earthwork. When possible, the contractor should maximize use of off-road trucks versus on-road haulers. And when space is available, the contractor should utilize a roundabout load orientation in order to reduce load times. This concludes our brief. We welcome any questions you might have.